Hi everyone and welcome back for another episode on Factorio. Today we'll learn how to produce a full belt of red circuits with the different assembling machine types to fill the three different belts. By the end, you will know how to set up a red circuits production, how much power it consumes, how much pollution it produces, and how much resources are required. This should help to understand how to produce red circuits efficiently. With that said, let's get started. Different approaches can be taken when it comes to the design. We can decide to add the copper wires production to this production line, or we can separate it. It does make a big difference. Here is a small example of how it would look like with having the copper wire production included. The only thing to keep in mind is that the ratio to produce a copper wire from copper plate is 1 to 2, meaning that one copper plate produces two copper wires, and therefore one belt of copper plate can produce two belts of copper wire. So here, on each side, we have only 5 assembling machines that produce red circuits. To do so, it requires 0.33 copper wires each second. It means we only need 0.825 copper plates each second to be able to produce the required 1.65 copper wires. It can be achieved with a single assembling machine because it produces 2 copper wire each second, but for a higher production, it will require to have more of those copper wire assembling machines, which can complicate the design. So for simplicity, we will separate them. Let's now jump to a more realistic production design. We already know each assembling machine requires 0.33 copper wire per second, but it also requires electronic circuits and plastic bars as well. They both will be consumed at a rate of 0.166 per second, which is twice as much as the copper wires. Here in our design, we use two belts with green circuits and plastic bars to feed the assembling machines, but don't get confused, they both have half of each resource, meaning a single belt of those resources is required. Now we want to understand how many machines can fit on a single production line. To do so, we need to identify what is the limiting input resource that a single belt can carry. It is fairly straightforward. The resource with the higher consumption rate is our limiting resource. In this case, it is the copper wire because it has a consumption rate of 0.33 per second. We then need to identify whether the input consumption rate limits us or the output does. The output will also be placed on a yellow belt that can carry a maximum of 15 items per second. In this case, we can see that the production of red circuits is very slow with a speed of 0.08 items per second. It is significantly lower than the consumption rates of the copper wire, which is of 0.33. With this information, we can start figuring out how many machines can be placed on a single production line. To do so, we divide the belt capacity 15 items per second by our limiting rate 0.33 items per second. It gives us a number just slightly above 45, which means we can fit at most 45 assembling machines per production line. Here we can see there are two production lines, so they can each have 45 assembling machines. There are a few extra assembling machines placed at the end of the production line, and we can see they are idling because they can't consume copper wire. Therefore, it is useless to place more assembling machines. We now get a rough idea on how to design the production line, but do we produce enough red circuits? Not really. With a production rate of 0.083 items per second, that only produces 3.75 red circuits per second. It is also important to understand how much input resources we need to run this setup, because if it falls short on those resources, the design won't be able to have a consistent throughput. We already know that each production line will require 15 copper wires, and it will require half of that amount for the plastic bar and the electronic circuits, which is 7.5. Another way to calculate the resource required is to multiply the consumption rate by the amount of assembling machines. Given one production line only produces 3.75 items per second, and we have two of them, we are only producing 7.5 items per second. That is half a belt. We need to double the production lines to meet the demand. To be exact, we need an extra 90 assembling machines producing red circuits to produce a full yellow belt of red circuits. We will therefore add the extra assembling machines. This whole setup will now produce 15 red circuits, but it will also consume 30 plastic bars per second, 30 electric circuits per second, and 60 copper wires per second. To run this setup, we need inserters. We use long-handed inserters and yellow inserters. Choosing faster inserters consume more power, so to control the power consumption, it is always better to go with only what we need. We will now look at the design to produce 30 items per second. It is going to be similar as the ratio between the different input and output resources remains the same. The difference is that we expect to double the output. Unfortunately, the production rate does not double when upgrading to an assembling machine of level 2. Therefore, we will need extra assembling machines to meet the demand. The copper wire is still the limiting resource and is now consumed at a rate of 0.5 per second for each assembling machine. The production rate has increased by about 50%, which brings us to 0.125 red circuits produced every second for one assembling machine. To get 30 items per second, we need 240 assembling machines, that is 4 production lines of 60. To reach that production, the recovery resources will double as well, with 60 electronic circuits and plastic bars needed, and 120 copper wires. The production rate is still not that fast, meaning that we don't need to move the resources in or out of the assembling machines quickly. For that reason, we can keep using yellow and long-handed inserters. When upgrading to assembling machines of type 3, there will not be any massive changes to the design either, as the ratio remains the same. What changes is that now we need to produce 45 items per second, because we want to fill a blue belt that has a capacity of 45 items per second. The assembling machines also have a crafting speed increase from 0.75 to 1.25, so they will be faster. With this crafting speed, it will produce a little bit more than 0.2 red circuits each second, which means we need 216 assembling machines to produce 45 items per second with this crafting speed. It means we will need 4 lines of 54 assembling machines. To support this production, we will also need to increase the supply with 90 electronic circuits and plastic bars and 180 copper wires. Here the yellow inserters will need to be able to move at least 2 items at a time to keep up with the production speed. It should not be a problem once in that stage in the game, but if it is, fast inserters can be used. If the inserters can't keep up, there will be gaps in the output belt. Now that we have seen how to produce red circuits, it would be interesting to see how much power it consumes and how much pollution it produces for the different belts. To calculate the power consumption, not only we need to consider the assembling machines, but also the inserters associated with them. The power consumption ranges from just above 23,000 kW to just below 95,000 kW. We can also notice that upgrading from assembling machines type 2 to type 3 is expensive, as the production is only increased by 50%, but the power consumption is doubled. Here is a summary of how many of the different buildings would be required to produce enough power to meet the demand. Regarding the pollution, only the assembling machine produces pollution and ranges from 432 to 720. The pollution decreases as the assembling machines are upgraded, as the more advanced assembling machines produce less pollution. Here is a quick summary of the resources needed to produce red circuits.